Alright, we're going to work on 7.4 where we're adding and subtracting, and I guess multiplying radical expressions. But anyway, if we're adding and subtracting, basically they need to be like radicals. Just like terms, they need to be exactly the same. For instance, I'm going to do this pretty straightforward. 3x plus 5x is equal to 8x. As a reminder, what you're technically doing is you're factoring out an x in the problem, and then you have 3 plus 5. 3 plus 5 equals 8. Well, it's the same thing for radicals. You can think about factoring out a root 17 and then adding the pieces together. Or you can just understand like radicals mean they have to be exactly the same index too. Same index and same radicand, that's what that number is called. And the answer is 8 root 17. I think I've over-explained this already. So notice the next one. The index is the same, the radicand is the same, so we can combine them together, and 7 minus 12 is negative 5 cube root of 5z. And as you look at the third example in exercise 1, the index is not the same, so we cannot put them together. This one cannot be simplified, or you can just rewrite that answer. So I'm fine if you rewrite it, or if you just say cannot be combined, simplified, whatever phrase you want to use. Just make sure it's correct. Now here's the thing, is as you look at some problems, it might not look like you can simplify. But beware, because you can factor tree down and you can simplify. So like 8 times 3, 4 times 2, 2 times 2. So we have a pair of 2's that we can bring in front. Root 2 times 3 would be 6. And same thing with this one. We can break out 54, which, 9 times 6, 3 times 3. You can try to break down 6, but there's no pairs there. And remember, this 3 right here needs to be multiplied by that 3 that we bring in front. So we're looking at 9 root 6. So what started out as not like radicals actually is like radicals. And it equals 11 root 6. Feel free to pause or try to work this out on your own and see if you agree. I do want to point out, though, you can check with your calculator. As far as I know, though, your calculator will not give you the exact answer. Like if you were to type in square root of 24 plus, you forgot the number, 3 root 54. I don't think it'll give you the right answer. But you can double check that you're right by typing in the answer you get, and it should be identical, an identical decimal if you're doing it correctly, which I did. Now the next one definitely cannot be combined because the radicals are different, but I do want you to practice like what can you factor out. So this first one, because the index is 2, you factor out a 2, so that's 2 square root 10, but if you do the same work for this one, it's the same number, so it breaks down as 2, 2, 2, and 5. I do want you to practice that this is the same thing as 2 cube root of 5. But you cannot combine them. The radicals are different. One's a cube root, one's a square root. The index is different, but then obviously that's all we can do then. And then we have one more similar to this where, and we pretty much did this over here. So let me just break down the numbers quickly. 2, 2, 2, and 3. If you don't believe me, we worked it out over here. We have a cube root. So we have 3 2's that we can bring in front. Cube root of 3x. Let's see if we can do the same thing over here. Let's see. If I do this quickly in my head, it's 3 times 3 times 3 times 3. Right? 3, 9, 27, 81. And there's still an x right there. Don't forget that we have to multiply by this 4 that's in front. So it's really 12 cube root of 3x. And if it helps, you can write this as plus 1 cube root of 3x. So as you combine like terms, like radicals, I should say. 2 minus 12 is negative 10, plus 1 would be negative 9 cube root of 3x. Notice all of them had to have the same index and radicand in order to combine them together. And a few more examples. Let's see, I'm missing my division in here for some reason. Is trying to get you to practice. There's a division in here as well. Some slightly different problems. So if I were doing this, though, I would try to add and subtract and get the same denominators. So that would be my first thing. Maybe that wouldn't even be my first thing. I would probably simplify this 28. So like off to the side, I'm thinking that 28 breaks down as 7 and 4. 4 breaks down as 2 and 2. So what we're looking at is 2 root 7 over 3 minus 1 root 7 over 4. And maybe from there, that's when I would actually, multiply this fraction by 4 and this fraction by 3 over 3. That way I can quickly see, because now I'm getting the same denominator to be 12. And up here I have 8 root 7 minus 3 root 7. Well, 8 minus 3 would be 5 root 7 all over 12. And don't forget, your calculator will double check that you get the right answer. So I'm just throwing that out for you. I feel like I could do the next one pretty quickly. I'm not trying to just rush through this, but if you're understanding it, then it's a good thing. For instance, I hope you guys realize that the cube root of each piece, well, the cube root of 64, it's 4 times 4 times 4. So the cube root of 64 is just 4. And when I move it in front, I'm actually going to make it 1/4 because it's in the denominator. Cube root of 6y. So when I add it to this 3 cube root, oops, I wrote that wrong, of 6y, I think it's pretty evident that this would be 3 and 1/4. But if you've learned anything from me, you probably have learned that I prefer fractions. I would change this 3 to be 12/4. Right, 12/4 equals 3. So then I can add 1/4 to that. So I'm looking at 13/4 cube root of 6y. And that's just how I would do the problem. So notice that the book is trying to come up with difficult problems. So feel free to write anything down, question me. That's totally fine. Okay. In exercise 4, we have a lot of examples of just getting you to practice. A little bit tricky. I don't know how tricky it is because you know to distribute and then simplify. Now make sure that you're only multiplying radicals with radicals. For instance, I've seen students write this as the square root of 10, but that's wrong because the 2 is not the square root. We're looking at 2 root 5. And now it is okay to do root 5 times root 15, which is root 75. Now, I do want you to practice simplifying root 75 because you can break it down as 25 times 3 and then 5 times 5. So the answer I would like to see is you can't do anything with that 2 root 5, but you can bring that pair of 5s in front, root 3. That's what I would like to see for this answer. Let's see, the natural progression would probably be to go to this problem. But notice that you're just distributing or foiling, if you prefer to write it that way. Again, radical with radical, and then simplify. So we're looking at root 12 plus 2 root 2 minus root 30 minus 2 root 5. Now here's the thing, is some of these might simplify and some of them might reduce or be combined with other like radicals. For instance, 12, I can break down as 4 and 3 and 2 and 2. All right, so we're looking at that is equal to 2 root 3, which cannot be combined with root 2 or root 5 because those are not like radicals. Let me move over to root 30 though, because that is like with something else. I believe it is. No, it's not. 3 and 10, and then 2 and 5. There's no pairs. So really there's nothing else to do after that. because there's no pairs to bring in front for root 30, so just leave it as a square root of 30. And there's nothing else like. No other like radicals. So that's it. As I move on to the next row of problems, remember squaring something means the same thing as multiplying by itself. So we're looking at root 6 minus 3 times root 6 minus 3. And I hope you've done enough of these where you understand that root 6 times root 6 will be the square root of 36. And the square root of 36 is 6. The outside term would be negative 3 root 6. The inside is another negative 3 root 6. That is a total of negative 6 root 6. And negative 3 times negative 3 gives me positive 9. But just like before, I do want you to simplify where you can, and not having a radical is just like being a like radical. So the best answer that I want to see is 15, 6 plus 9, minus 6 root 6. As I move on, again, you just have to write down your questions and bring them to me if you have them. As I'm foiling, 3 times 2 would give me 6. Root z times root z will just give you z. The outside would give me 9 square root z. The inside would give me minus 8 square root z. And then negative 4 times positive 3 gives me negative 12. But just like before, you can have like terms in here, which we have 9 minus 8 is 1 root z minus 12. Now, as we get to a little bit tougher of problems, this is my opinion, by the way. You might agree, you might disagree that these are tough problems. Squaring means multiply by itself. So as I FOIL or distribute, 3 times 3 is 9. The outside would be 3 radical x plus 2. The inside is another 3 radical x plus 2. That is a total of 6 root x plus 2. Now the last piece that I'm going to have is the square root of x plus 2 times the square root of x plus 2 will undo the square root. So you're just left with x plus 2 from that. However, I do want you to take it a step further and think about that you can combine like terms. 9 plus 2 is 11. So that's how I want to see that answer. And then just one more. If you notice that these binomials look identical except one is plus and one's minus, that's indicating that the outside and inside terms will cancel. If you don't believe me, let's work it out. Root 5x times root 5x. Again, the radical will cancel just like over here. So you'll get 5x. The outside term would be minus 3 root 5x. Again, only multiply radicals with radicals. The inside is plus 3 root 5x. And 3 times negative 3 give me negative 9. But just like I promised, the outside and inside terms will cancel. So we're just left with 5x minus 9 as our final answer. Okay, I don't want to rush through the last bit of notes. Oh, I guess that's it. No need to rush. I'm done with this. Notice I'm asking you to do multiples of 4, so 4, 8, 12, 16. Pretty much if it's divisible by 4, then do that number. And then after you get to 76, jump to 85. Okay, so there is one odd problem in this homework. And you're free to get going on it. There you go, no second video.